what's up, fellas? I got to do a quick video about the PSAN V01 CPV. That is this little module right here, just this pressure sensor box. And the instructions this thing comes with leave a lot to be desired. I showed a company how to use this thing to run some augers a while back, and I went to use it again for a gas burner setup I'm building, and I forgot how to do it. It's very difficult, so I'm making this instructional video for myself. So I can come back to it later and I've got it all figured out now. So basically what we have here is the pressure sensor switch. And this particular one has a very narrow band of pressure that it operates under. It's a vacuum switch, more or less. So these are solid state relays that are going to be actuated by the pressure sensor. And we have a normally closed AC solenoid. So right now, they're on normally closed, as you can see. And so when I apply pressure to this syringe, it's going to turn on the gas flow to the system. This would show that the blower is on and everything's safe. So that's kind of what we have here. So when this hits like 0.1, that's it. We should get some gas here. There you go. But let's say the blower turns off. So let's say this is a gas valve to a burner and we lose the blower. We need to be able to shut the gas off in the event the blower's off. And we don't want the gas to turn on if the blowers aren't on. So I'm going to induce some pressure to simulate the blower being turned on, and we're going to hear the gas pressure turn on. This is just air to simulate the effects. When this hits 0.2, it will turn on. We're right now at negative 0.1. If the power just flat out goes out in the building or whatever, then that valve will automatically shut off. But hysteresis mode, and the way you switch through the modes is just cycle through by holding the button in like it says, and it will flash what mode you're on, and then it will flash what setting you're on. Right now we have it set to kilopascals. So what we need to do now is go to this section here, and we need to change this to this, because we want one of these to be normally closed and one of these to be normally opened. We're going to try output 1, so we're going to want to go with this IO2C. We're going to want to try to go with this right here so that this thing will turn on when we exceed a certain pressure. I want to be able to build a imitation air regulator out of this. I want to make an air regulator, so we got to invert normally closed to normally opened. And this is how we do that. We're going to hold it on just like it says. Now that's right there is showing the top. When we press it again, it's not what we want though. Or yeah, it is. We want to go down one more. We have NONC. And it's showing we're right now on IC2C. This right here. We are currently on IC2C, which is normally closed, normally closed. So we're going to move that IO2C. That right there. IO2C, and we're going to go with that. Okay, now, when the pressure exceeds 1, it shuts off. This one turns on. I want to have them like that on purpose. So let's say we want to set a regulator that does 2 PSIs of pressure. I need to take some propane at 100 PSIs and regulate it down to 2 PSIs to imitate a natural gas burner that I'm working on. All right. See here I have 2 gauges set up. And when I open this propane valve right here, this check valve is going to shut off when this reaches, I think it was 2 pascals. So here goes. I'm going to do that now. And it shut off already. It went up to 4.2, but that's okay. It wasn't quick enough shutting it down, I think is what happened there. But once we get things going, it should keep that off. And this other pressure gauge is connected to our blower. And we'll spin this around. And that one there's our blower on the left, and that's our fuel on the right. Working. I should probably lower it. So far so good. I'm going to turn the air up just a bit, I think. I'm going to just let it run like that for a while, because the main purpose of this is I need to cure that refractory. And to do that, we gotta let it get hot inside of there. We got 3 jets not lit, so I think I'll put my flame rod right there on the top right corner. Take it down to 3 or 4. And we'll make the hysteresis be 4.5. That way you can see what I'm talking about. That's fine. Okay, so now when the pressure goes below 4.5, the flow will turn on. Or below 4. But it's not going to turn off until it hits that 4.5. See that? It didn't turn off until it hit 4.5 because we had the hysteresis or the hysteresis set. But it will turn, but it will let it bleed down to 4 before it turns back on. See that? It won't turn off till 4.5. It won't turn back on till 4.